Hi, welcome to Aether. This session talks all about virtual private cloud, a component of networking in AWS service. Here our focus will be on VPC concept and later how to build, configure and manage your own virtual private cloud in the lab session. Starting session with what is AWS VPC, what are its uses and different types of VPC supported by AWS. Further, how to build your own virtual private cloud. We will discuss in detail about the various components of AWS VPC like VPC CIDR Block, NAT, Subnets, gateways, route tables, internet gateways and focus on security mechanism in the context of AWS VPC, and at the end we will have a detailed lab session. So let's begin with VPC, which is a logically isolated virtual network in AWS region where your instances are launched. Since by now we have a clear understanding of AWS regions and availability zones, a region in AWS can have only one default VPC which AWS creates for you, although you can have up to 5 VPCs in a region. Now every AWS account which was created after December 2013 supports VPC, and these accounts are assigned a default VPC in every AWS region. These default VPCs are designed to make it easy for AWS users to set up networking for their EC2 instances. See, basically a VPC is primarily concerned with enabling the capabilities like isolating your AWS resources from other accounts, routing network traffic to and fro from your instances, protecting your instances from network intrusion. So let's understand what are its various components. There are 7 core components which are fundamental to a VPC and will be created by a user or by AWS as a part of a default VPC. Let's look at these components. First is VPC CIDR Block, NAT, Subnet, gateways, route table, network access control list, security groups. Now these basic components will already be provisioned as a part of default VPC that is assigned to every AWS account for every region. Further, to understand these components in detail, let's take up one by one. Our first is VPC CIDR Block. CIDR means classless interdomain routing. Every VPC is associated with an IP address range which is a part of CIDR block and will be used to allocate private IP addresses to EC2 instances. Now CIDR stands for classless interdomain routing and is used for allocating IP addresses in a more flexible manner as compared to the traditional system where we had 5 classes of IP addresses. CIDR IP addresses consist of 2 groups of numbers which are also referred to as groups of bits. One is network address, which is used to identify a network or a subnetwork. The other group is the host identifier. The host identifier is used to determine which host or device on the network should receive incoming information packets. CIDR blocks share the first part of the bit sequence that comprises the binary representation of IP address, and blocks are identified using the same decimal or dot CIDR notation system that is used for IPv4 addresses. For example, let's take up an IP address, say 192.168.0.0/23. This specifies that there are 23 bits which are used for network portion. Here the first 23 bits are marked as 1. It would be equivalent to a network mask of 255.255.254.0. Now how to calculate this network mask? Let's say another example. We have been given a notation of /20 as the mask. How can we calculate a network mask? We can do this with the help of the below table notation. For a mask of /20, the equivalent binary format would be as follows. From the third octet, we can see that there are 4 leading ones. This corresponds to the first 4 columns of our table. If we add these numbers, 128 plus 64 plus 32 plus 16, we get 240. Hence, our network mask would be 255.255.240.0. Further, we need to calculate subnets and host. So, based on CIDR block, let's say we need to calculate the number of subnets and hosts possible. We can do this with the following equations. Number of networks possible in a CIDR network. We use 2 to the power n, where n is the number of ones in the subnet mask. See, number of hosts possible in a CIDR network, we use 2 to the power n minus 10. We use 2 to the power n minus 2, where n is the number of zeros in the host mask. So every network needs 2 addresses, one for network and one for broadcast. Now let's understand CIDR for VPCs and subnets. See, the allowed range of CIDR block size for VPC is between a /16 network mask and /28 network mask. The CIDR block of a subnet can be same as that of block for the VPC. The CIDR block of a subnet can also be same as that of other subset in case of multiple subnets. In a subnet CIDR block, the first 4 IP addresses and the last IP address in each subnet block are not available to use and cannot be assigned to an instance. For example, in a subnet with a block 10.0.0.0/24, the following 5 IP addresses are reserved. 10.0.0.0 is network address, 11.0.0.1 reserved by AWS for VPC router, 12.0.0.2 reserved by AWS, 13.0.0.3 reserved by AWS for future use, 14.0.0.255 network broadcast address. So AWS recommends that VPCs use private ranges that are defined in RFC 1980. These private ranges are reserved by the Internet Assigned Number Authority (INA) and cannot be routed to the Internet. Different sized ranges with different allocations of IP addresses can be assigned to a VPC depending on need. Now, all default VPCs can be associated with the IPv4 CIDR block with a 172.31.0.0/16 address range. This will give you approximately 65,536 possible IP addresses minus some AWS reserved addresses. VPCs can be created with smaller CIDR blocks such as /20, which would yield 4091 possible addresses. I hope CIDR block is clear. Our next important component is NAT Gateway. The topic NAT Gateway actually addresses the design and implementation of AWS networks as highlighted in AWS Blueprint for Exam Guide. It is also shown in lab at the end of the session. So what is Network Address Translation Gateway? A NAT device forwards traffic from the instance in a private subnet to the internet or other AWS services and then sends the response back to the instance. NAT device is used to enable instances in a private subnet to connect to the internet, for example, for software updates or other AWS services. When traffic goes to the internet, the source IPv4 address is replaced with the NAT device's address, and similarly, when the response traffic goes to those instances, the NAT device translates the address back to those instances. See, NAT devices are not supported for IPv6 traffic. Hence, an egress-only internet gateway is used. AWS offers 2 kinds of NAT devices, a NAT gateway or a NAT instance. NAT gateway service is managed service and does not require your administration effort, and they provide better availability and bandwidth over NAT instances, also recommended over NAT instances. NAT gateways in each availability zone are implemented with redundancy, hence it can always be ensured that it will be up and running. With the NAT instance, you have an additional maintenance overhead to ensuring the instance is always up and running, hence takes care of high availability feature. Another important feature is bandwidth. By default, the NAT gateway supports burst of up to 10 Gbps. For NAT instance, this will depend on instance type of the instance. Maintenance, another important feature. All of the maintenance of NAT gateway is performed by AWS. In comparison, if you had a NAT instance, you would need to perform all the maintenance. Some of the reasons why you would want to use a NAT instance are in situations where you would want the NAT instance to also be a Western host, for the NAT instance to also provide port forwarding. NAT devices are not supported for IPv6 traffic. Use an egress-only internet gateway instead, as said earlier. Egress-only internet gateway allows outbound communication over IPv6 from instances in your VPC to the internet, and it prevents the internet from initiating an IPv6 connection with your instances. An egress-only internet gateway is for use with IPv6 traffic only. An egress-only internet gateway has the following characteristic. You cannot associate a security group with an egress-only internet gateway. You can use security groups for your instance in the private subnet to control the traffic to and fro from those instances. You can use a network ACL. is an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of one or more subnet. You might set up a network ACL with rules similar to your security groups in order to add an additional layer of security to your VPC. Basically, to control the traffic to and from the subnet for which the egress-only internet gateway routes traffic. Next important core component is subnet. See, a subnet is always associated with a single availability zone, but an availability zone can host multiple subnets. Each subnet in a VPC is associated with an IPv4 CIDR block that is a subset of /16 CIDR block of its VPC. In a default VPC, each default subnet is associated with /20 CIDR block address range, which will have 4091 possible IP addresses minus the 5 addresses AWS always reserves. Note that two subnets cannot have overlapping addresses ranges. See, when you launch an EC2 instance into a default VPC without specifying a specific subnet, it automatically launched in one of the default subnets. Every instance in a default subnet receives a private IP address from the pool of addresses associated with that subnet and also a private DNS host name. In a default subnet, an instance will also receive a public IP address from the pool of addresses owned by AWS along with the public DNS hostname, which will facilitate internet access for your instances. Moving further to gateways, frequently your EC2 instances will require connectivity outside of AWS to the internet or to a user's corporate network via the use of gateways. So for communication with the internet, a VPC must be attached to an internet gateway. An internet gateway actually is a fully managed AWS service that performs bidirectional source and destination network address translation for your EC2 instances. Optionally, a VPC may use a virtual private gateway to grant instance secure access to a user's corporate network via VPN or direct connect links. Now, instances in a subnet can also be granted outbound only internet access through a NAT gateway. A subnet that provides its instances a route to an internet gateway is considered a public subnet. A private subnet may be in a VPC with an attached internet gateway but will not have a route to do that gateway. In a default VPC, all default subnets are public subnets and will have a route to a default gateway. So this was all about gateways. Moving further to route table, you will be able to understand much better when we'll be doing lab session. So what happens is every VPC is attached to an implicit router. This router is not visible to user but is fully managed and scaled by AWS. What is visible is the route table associated with each subnet, which is used by the VPC router to determine the allowed routes for outbound network traffic leaving a subnet. See, every route table contains a default local route to facilitate communication between instances in the same VPC even across subnets. This intra-VPC local route is implied and cannot be changed. In the case of main route table that is associated with the default subnet, there will also be a route out to the internet via default gateway for the VPC. Also note that every subnet must be associated with the route table. If the association is not explicitly defined, then the subnet will be implicitly associated with the main route table. Further talking about network security. One concern you may have is network security, particularly if all default subnet in a default VPC are public and open to internet traffic. AWS provides security mechanism for your instances in the form of network ACLs and security groups. So these two mechanisms can work together to provide a layered protection for your EC2 instances. So basically, an ACL acts as a firewall that controls network traffic in and out of a subnet. You create rules for allowing or denying network traffic for specific protocols, those specific ports and for specific IP addresses ranges. Now, network ACLs are stateless and have separate inbound and outbound rules. This means that both inbound and outbound rules have to be created to allow certain network traffic to enter the subnet and for responses to go back though. So a number is assigned to each rule and all rules are evaluated starting with the lowest numbered rule when the traffic hits the firewall. it is evaluated against the rules in ascending order. As soon as the rule is evaluated that matches the traffic being considered, it is applied regardless of what is indicated in the subsequent rule. So as we said, the default ACL in a default VPC is configured with a lower numbered rules for both inbound and outbound traffic, which combine to explicitly allow bidirectional communication for any protocol, though any port to and from any source or destination. You can associate an ACL with multiple subnets, but any single subnet can only be associated with one ACL. If you don't specifically associate an ACL with a subnet, the subnet is automatically associated with the default ACL. This is the case with your default VPCs, which have all subnets associated with the default ACL. We will discuss about stateless and stateful filtering in a while. So before that, we would like to talk about security groups. See, security groups are considered the first line of defense and consist of firewall that's applied at the instance level. This means only instances explicitly associated with the security group will be subject to its rule, while all instances in subject are impacted by the network ACL applied to that. Similarly to ACLs, you create inbound and outbound traffic rules based on protocol, port and source or destination IP. However, there are some differences. You can specify rules to allow network traffic but cannot create rules to deny specific types of traffic. In essence, all traffic is denied except for traffic you explicitly allow. Security groups are stateful, so if you create a rule to allow a certain type of traffic in, then outbound traffic in response is also allowed even there is no explicit outbound rule to allow such traffic. Every instance must also be associated with a security group. If a security group is not specified at the launch time, then the instance will be associated with the default security group. The default security group will have a rule that only allows inbound traffic from other instances that are associated with the same default security group. No other inbound traffic is allowed. Looking at the outbound rules above, all network traffic out is allowed by the default security group. This includes traffic out to the internet, since a default VPC will have a route to the default internet gateway. While the default security group can be modified, we don't recommend making any changes to it. Instead, Rackspace recommends creating new security group that can be attached to resources. As you can imagine, a default VPC may be suitable for a small non-critical single-tier application, but it is not ideal for a robust production environment. That's often why user will modify their default VPC configuration once they become more familiar with the technology, and even create custom VPCs for production use, stateful versus stateless filtering. To understand stateful and stateless, let us consider examples. Here, security groups are stateful, means traffic allowed at ingress or egress will automatically be allowed and unfiltered return. In order to allow SSH traffic through our security group to our instance, we open the relevant inbound port, TCP22, to the appropriate network space. We can now successfully initiate connections to and receive responses from our instance. We can even delete the default outbound rule without impacting our inbound connections. Whereas NACL is stateless, traffic must be explicitly allowed at both ingress and egress. Inbound is simple, open TCP22 to the appropriate address space just like our security group. Outbound, however, is slightly different. Return traffic does not make connections on TCP22. Instead, the server chooses arbitrarily high numbered ports by which to establish the second half of the connection pair. These ports are often referred to as ephemeral ports. Unfortunately, these ports are chosen at random by the server. You only need to open a range for the return traffic to flow, depending on various factors. Range can vary, but in general, you'll need to open something between TCP 1024 to TCP 65535. Once these ports are open, response traffic will begin to flow. Now, further moving to our lab session that will help you to clear all the details which we had discussed in the topic. Let's move to the lab.
Let's have a lab session on Virtual Private Cloud VPC, which is one of the most fundamental topics of AWS. Okay, so what I want to do is I'll go ahead and build a VPC from scratch, and I will try to cover the different aspects of it so that you understand that how does it work. Okay, fine, so let us get started. I'll switch to a particular region, let us say it is Mumbai, and okay. I will go to the networking service and select VPC service. VPC dashboard comes up and we will see that there is one VPC already there, so which is the default VPC. AWS gives you a default VPC in every region. It is just for the purpose that when you are getting started and you don't know how to create a VPC, there is a VPC for you for default. You can go ahead and it will just quickly create EC2 instances for that particularly VPC, but do not use this default VPC for your customer deployments. So our intention is to learn how to create a VPC. Alright, so let us go and click on your VPCs. I'll say create now. I can go ahead and give it a name. I call it my VPC and I need to give a CIDR block, so that's I'm giving 10.0.0.0.0/26. I am keeping that intensity fall. There's another tenant cells available as well, dedicated. If you choose dedicated, then you will be able to launch only dedicated instances or dedicated host instances. In this particular VPC we don't want to do that, so if you are choosing default, then you can launch all three types of the EC2 instances within that, which are shared dedicated instances and dedicated hosting. I'm going to keep it default and move forward. I hope you understand what this particular CIDR block means. It represents a range of IP address. Okay, fine, so we'll go ahead and do that. I'll say okay, services created. Next we go ahead and divide this VPC into subnets right now. Understand that we exists into a particular region. You did not give any availabilities on there. One VPC cannot span acrossly, so I've created this particularly VPC in Mumbai region. I go further and now I go to the subnet, so these are the two subnets which are there. To create VPC I will go ahead and say create subnet. I will give it a name. I'm going to call it private AA because I will be creating it in the availability zone, and I will choose my VPC, and now we need to give it a range of IP address basically in the CIDR format, so I am going to divide the 64 IP addresses into 4 blocks right on, basically into 4 subnets of 16 IP addressing. So I'm going to put it like this: not 2 to the power 32 minus 28 is 2 to the power 4, which is 16, so that makes sense. This particular thing will start from 0 and end at 16. Okay. Alright, I can just filter so that we see only the ones which we are creating. Now okay, to create one more private, and this time the other will build. Let's go right then. 16, so first one was there up to 15, so second one starts from 16 and report like this. Okay, so following the principle of higher availability, we are creating 2 subnets private and 2 subnets public, both in different availability zones. Alright, let's go ahead create 2 public subnet cells with the same manner. Okay, we do it in 8 and the third time 32/gate, so the second one ended at 31. So this one is starting at 32 and this one will end at 47, and next one will start at 48. So like this all our 4 subnets will get great. Now remember, if you try to give a CIDR block which is conflicting, meaning if you try to give a range which is already used, then it will give you error itself, right? Basically subnets cannot clash in terms of IP addresses, right? Okay. Now you can see we have what 4 subjects created. Here you can see the availability zone. As well, right here now something to remember, we have divided it into 4 subnets of 16 IP addresses, but the available IP addresses are only 11 in all. This is because whenever you create a subnet on AWS, 5 IP addresses are reserved or kept for internal usage which will not be available to you. So what are those 5 IP addresses in every subnet? The first 4 and the last 1 IP address. So these 5 IP addresses would not be available to all. Right now we move to the next important thing, which is route tables. Now as you can see, you have one route table available with your VPC which you have created. With any VPC, one route table gets created by default, and that is for the main route table of your VPC. You see the main attribute as yes. Okay, I'll go ahead and just rename it as for our convenience. I am going to call it say public RT. Okay, I will also create one more or table, so this is going to be custom variable. I'm going to call it private RT and 1. Now I am creating one public and one private, the public route table. It is going to get associated to the public subnets and private one to the privates. Next, so you can see currently none of them are associated to anything explicitly, so it is also important to understand that if there is no route table explicitly associated to a subnet, the main route table of that VPC will be used for the subnet. So if I don't go into any explicit association, automatically the main route table will be used for all the subnets, but we will go ahead and do the explicit association. Now let us go ahead and do that. We can just do it here. To go to the subnet association place, hit it, so this one is private associated with the both the private ones is save it. We'll see the number changing here to 2. Now choose the second one, and we do this in here. Now we're associated with both the public ones. Okay, save it. So remember that one subnet can have only one route table, or meaning one subnet can have only one route table associated to it, but one route table can be associated to multiple subnets. That is possible. We did it just now. So this both the route tables you see are associated to two subnets, right? Okay. Now we need to go and do some change here, because currently if you see, look at the routes in both of our table, it is seen, so there's no difference in them. Now let's move to Internet Gateway. It is an entity to connect to your VPC to the internet. Let's create an Internet Gateway for our VPC. Click on Create and give name to it. Click on Yes, Create. Now you can see your Internet Gateway is created. By default it is detached, so you have to attach it with your VPC. Follow as I do. Now it is attached to the VPC. Now we need to attach the Internet Gateway to our public route table. I will go to route table and select public RT route table. In the route, click on Edit. In Edit you can find Add another route button. Click on it and give CIDR address as shown and attach the gateway to it. Now let's create NAT Gateway for our private subnets. Click on NAT Gateway. On the dashboard you can see Create option, click on it. You have to give public subnet, so I will select it and will generate the IP from the button below. Watch it carefully. NAT Gateway is created. Next you have to edit the route table and attach this NAT Gateway to it. Hit on Edit Route Table. In public route table Internet Gateway is added. Now we will add this NAT Gateway to the private route table. Click on Private Route Table Edit Route option. Hit Edit and give the CIDR IP and provide NAT Gateway and save it. Now Internet Gateway is mapped to public route table and NAT Gateway to private route table. We have created intermediate gateway, we have created NAT gateways. Well, let's quickly understand what is the use of NAT Gateway. NAT Gateway helps all the outbound internet-bound traffic which is getting originated from your private instances to go to internet, and then it gets that applied from the internet. Now go to subnet and you can see in public C subnet there is only 10 IP addresses available, while other has 11, one IP address is reserved for NAT Gateway. Now we have to assign auto IP settings for the public IP address, so I will go to public subnets and click on auto assign setting, and click on checkbox. I will do same for the both public subnets. Now go to your VPC tab and select your VPC. Then you have to enable DNS resolution to yes. Which means this property will be shown when you are launching instances in this particular subnet, so we want that when instances are being launched in the public subnet they should get a public IP. That's why we are making this particular property as true. And also modify DNS hostname to yes, the instance is launched in this particular way, we see they get a private hostname. Make the modification as shown. Now we have completely set up our VPC. Now it's time to check how it works. Go to EC2 and create two instances, one is for private and other is for public. I will use Windows 2008 Server AMI for this instance. Follow the steps for creating the instance. Creating our first EC2 instance for public. In the Configure Instance tab, give your VPC name and your public subnet name. Rest of the settings are fine for now and hit next. On the Tag tab, give name tag, and I am giving it public EC2. Hit on next. Now on security group, just change the name of the group and rest of the settings are fine. Click on Launch Instance, and confirm it. Create a key as we don't have key and download it. Launch the instance, it will take some time to prepare instance for use. While it is being prepared, let's create another instance for private. Make the same setting as you did in creating public EC2 instance. Only give subnet as private and at security group give any name other than previous one. Now you have already created a key pair value, so we are going to use the same value. So I gave it the same key pair value and click on Launch Instance. It is also preparing. Now we will go to the security group of each instances and add new rule to the inbound. We will provide port range as 80 because it is used for HTTP inbound traffic. Do this same for both the instances as shown. Now let's create the Windows user and passwords from the key pair value. Our public instance has been initialized, so we will get its password. Upload the key pair file and you will get the Windows password. Do as shown. We got our public instance login password. I will save it on Notepad. It will be used to log into the server. Private instance has been also initialized, so we will get its login and password as well. We will follow the same way to generate its password. Upload the key pair file and decrypt the password. Here you go. Now save this value also on the Notepad. Let's connect our instance. For this you will need a remote desktop connection tool. Let's download it. Now run the tool. It will ask for user and password. Provide it from the notepad that we just saved. Now it's login. Basically it's like your Windows computer. You can use it as your PC. It will take little time to prepare your desktop. Now it has been prepared. It is ready to use. Now we will connect our private instance with this instance. So we will connect private instance using remote desktop connection tool. We have got the IP address of the private network. Provide it to connect. Now give the username and password. It will also prepare your private desktop. Basically 3 desktops are running currently. It will also take little time to configure. Wait till it is not prepared. Now both the instances are ready to use. Let's go to the public and click on Manage Computer tool. And click on Roles. It will take little time to populate, Till it is loading, let's do the same in the private instance. Click on the Manage Computer tool and hit on Roles. It's populating. It has been populated. Now add new roles to it. A new window will pop up. Click on Next and on the next page select IIS from the list and click on Next. And finish it. Do the same on public instance as well. Follow the same method. IIS is installed on both the instances. Now go to the EC2 instance dashboard and copy the public IP address, and paste it on the other tab of the browser. You can see it is showing IIS on the tab. Now go to public instance window, open the browser. Copy the IP of private instance and paste it on the browser. It will also show IIS page on the screen. It means that you have installed IIS on both the instances. You cannot access the private instance from the outside. Any traffic to the private IP will have to go through public. This is the basic role of VPC. You must have understood why to use VPC. Now for using internet from private instance, you have to add certificates to it. As it is not allowed to connect from the outside of the public instance, so you need to provide access or verify it. Go to the private instance and open the browser. Try to open the google.com. You will see it asks for the certificates to connect. Click on Yes to provide it. Now you can see Google is opened on your screen. Now we will see how VPC ACL works. ACL are the rules that define the inbound traffic. Click on ACL. On your VPC ACL, click on it and you will get a DOS board below. Click on Inbound Rule. Here is the list of some rule. First column is an integer number, it follows the lowest number rule. If you create some rule for value 500, then it will be overridden by the lower value. Now I create the value as 50 and deny the access. Then go to browser and check, it will not work. Once I change the value, greater than 100, it will override the value at 100 and allow the traffic, and now you can see the IIS again on your browser.
Hope you all had a great lab session on VPC. That's all about VPC, a network service by Amazon. Stay tuned for our next session on AWS Network Service Route 53. Thank you.